Hi guys, in this video we're going to go through another question involving Hungarian algorithm, but in this case we want to maximize the completion time. Now with this, if you have to maximize the completion time, you've got to subtract every value from the biggest number. So in this case, if I look at this whole matrix, we can see that the biggest number is 150. So what we're going to do is we're going to subtract every single value from 150 to get the new values. So notice the first number here is 100. So I'm going to subtract 100 from 150 and I'm going to write that value in. I'm going to now do the same thing for 90. So 150 take away 90 gives me 60. I'm going to do the same thing for this value. So 150 take away 30 is 20. And I'm going to continue that. So 150 take 75 is 75. And I've gone and repeated that for every single value. Now, all you've got to do is just complete Hungarian algorithm as normal, which will give you the maximum completion time once you've finished. So first things first, I'm going to do my row reduction. Remember, row reduction and column reduction can be done in either order. I've just randomly chosen to do row reduction first, which is where you subtract the smallest value from each row from each number in that row. So that's what I get when I subtract the smallest value from each row. Now I'm going to do column reduction. So I'm subtracting the smallest number from each column, from each value. That's what I get once I do that step. So now I need to cover all zeros in the least number of horizontal and vertical lines possible. And notice that this took me 4 lines minimum to be able to do that. Because this is a 4x4 matrix, I can stop here. I'm done. Now I can start to assign tasks based on where the zeros are. So because for row A, we've got a 0 with Y and Z, that means that person A can do Y and Z. And then I've just gone and completed my bipartite graph for this matrix. Doing a bit of process of elimination stuff, so B can only do Y. That means that therefore B has to do job Y. Then A can only do Y or Z. So because B's already doing Y, that means that A must do job Z. And then C can only do Y or W, so therefore C must do job W. And then that means that D must do X because that's the only one left. Therefore, D does X. So now what I need to do is I just need to find the maximum completion time by referring back to the original matrix right at the beginning. And all I've done here is I've just written down the time it takes for each of these people to complete the job that has been assigned to them. So we've got 150, 175, 120, 100. And now if I add all of those values up, this is what I get, 455, which represents the maximum completion time. So just to rehash, this is the most important thing, right? Because the Hungarian algorithm is exactly the same in this video compared to the other video. But whenever you're maximizing, right? If a question ever says maximum completion time or maximum travel distance or whatever the context, whenever you're maximizing, step 1, which is the most important step, is to subtract each value from the biggest number. So find out what the biggest number is in your matrix and subtract each value from that number. So you have to do this for every single value. And once you've done that step, then you can get into just doing Hungarian algorithm as normal.